All right, so let's go over some a very fun little concept that I've kind of been learning, which is network address translation, right? NATs. So it's a very interesting topic that I'm learning. So of course, most of the stuff that I'm saying is kind of freestyled. I don't have like a script here or anything. So let's try to kind of capture everything that I've just learned here. So it's a very fun idea, right? So generally when you are on the internet, or let's think about it like this. So whenever we are learning networks, right, the idea is that if you're writing, let's say, a source IP, right? So if you write a source IP, say something like 192, let's go with 192.168 dot, let's say, 10.0 or something like this, what you would assume, or not, let's 10.0 is fine, 10.10, we'll make it that, right? So what you would generally assume is, this is, if this is your source IP, right, if this is sort of your source IP, and your destination is something like, let's say, 200.200.10.100, something like this, generally what would you assume? And I had this assumption just a while ago, right, like a couple of minutes ago, let's call it that. So the idea is that, I mean, of course, the way we think of it is, so if I have to send something from my side to the destination, what I have to do is basically, you'd kind of do all the packet and all that kind of stuff, application layer, and you choose your protocol, and then at the IP, right, at the IP level, what you would do is, you would essentially, this is what we think, right, that in the source IP you would write this particular 192.168 stuff, and then the destination part you would write this 200.200.10.10, and then you would basically send this IP packet, and then essentially that is how communication would happen, right? This is what we think happens, and funnily enough, this is actually not very accurate, right, because this is not how it works. And it's actually quite very fascinating, because they changed this up to like make things very interesting, right? So generally the way we have kind of learned about IP addresses is that they are unique, right? That is what we have learned, that IP addresses are unique, right? That these addresses are used to uniquely locate a single device, and that you can communicate from, you can basically do communication with a device if you know its IP address, because you can send packets or whatever, you get the idea, right? We have always been told that these IP addresses are unique, and then you can sort of locate any device using the IP address. That is amazing, that is completely fine. But the fun thing is, NATs kind of changed that whole thing, because what they did, now I think there's 3 or something different types of NAT, but I'll talk about the one that I just learned about, which is where you can actually have so many private IPs. Let me actually try to write it properly here. So many private IP and one public IP. So what does that mean? So the idea is, I think the name kind of gives it away. The idea here is that this IP that you have, let's say the source IP, right? Let's say I have this laptop here. This laptop's IP address is 192.168.10.10. What can also happen is that someone sitting literally like a couple of meters away in the next like home or whatever, they have their own router, they might have their own device, their device could also in a sense have this same IP address. It is very much possible, right? But it is of course only possible because I'm within my own network, right, and they are within their own network, right? So the way I'm kind of thinking about the network in that case is that it's more related to the router. So my router is different and their router is different, and I'm kind of drawing the boundary roughly like that. Now of course the difference might be quite a bit, it might be quite huge. So it might be the case that I have this IP address here, and maybe someone out there on the other side of the world actually has the same IP address. Whatever the case may be, the point is that it is no longer the case that only one person can have this particular IP address. And that makes things very crazy, because if that is the case, then how do you actually know who actually sent it, right? Because at any given point, then you can just assume that you could have, let's say, like n number of different people having that same IP address, and if they are sending, let's say, the same or different kind of request to a particular like server or something, like who gets what, right? I think that's a very fun question to ask, because that is very mind bending. I mean, why did you invent subnetting, right? At least that's where my mind went when I read about this, but then I kind of clarified it. So anyways, let's get into this very interesting little idea here. So I'll kind of try to walk you through what I've just understood about this whole idea, and that's about it. I don't have any kind of script or anything to go off of, so we'll just freestyle. So the idea is quite simple, right? So let us say that I have an IP address. Let's make a new one, 192.168. let's say 1. Some 100, Let us say this is my IP address. Like, let's say I'm in like some incredibly huge network with a subnet of 16, right, /16, incredibly huge network. Let us say this is my machine, right? Let's call my machine M1, right? M1. Yes, let's go with that. Now the fun thing is, let us say that I'm in this extremely huge network and I say, you know what, I want to try to contact server 1, which let's say it's like, it like has my you know, some backup files, whatever nonsense, you know, doesn't really matter. Let us say it is sitting in 192.168 .1 dot, let's say not 255, let's call it 240, something like that, right? It's basically within the same subnet, it is just here, right? So yeah, that's basically what is happening, right? Same subnet, same everything, except my device IP address is basically 1.100 and this one's is 1.240. Amazing. Now how would this communication happen? So generally what happens is, so my machine, my NIC, I think, which is the network interface controller, or what, I don't know what the full form is, right? The chipset, basically what it does is, it's going to look at this address, it's going to look at the source address that the destination address, it's going to look at our address, right? And it's going to go, oh, look at this, we are both in the same subnet, we are both also in the same we are both basically in the same network itself. It will perform the XOR AND check and it will be like, okay, so we are in the same we are in the same exact network. So amazing. And guess what happens? You don't actually sit down and like file an IP packet and then go, oh my god, let me call in TCP or UDP. UDP won't be used, but TCP, and I'll do my FTP that way. Nah, none of that happens. Actually, it doesn't seem like that happens at all, because what ends up happening is that when you are within the same network, what happens is completely different. Instead of using this routing system and any of that kind of stuff, you actually simply use hardware. So what happens is that this guy, so my machine here, what it will do is that it will go, okay, I want to send this packet, right? So the machine will go, okay, I want to send my or I want to do whatever, I want to send file, receive file from this particular IP address. So it will basically send a what is it called? It will basically send a broadcast, a multicast to, like, basically I think it's called ff.ff.ff. You write it like 8 times, right? So it's basically this, like I think you have seen it already, 255.255.255.255. It'll write that basically in hexadecimal 16, right? It'll write that, and basically what it'll do is it'll yell, it'll say at 255, hello, who has this particular IP address, please tell me what your MAC address is, I want to have a connection with you. And because this message that this guy screamed, M1 screamed, is at 255.255.255.255, every single device on the network will get that particular prompt. Now of course S1 will also get that message, and S1 will go, oh hello, let's converse privately, this is my MAC address, so yeah, what do you want to send, let's have a private little chat here. And that's when whatever file exchange, whatever nonsense has to happens through the MAC address. You don't even touch level 3, you don't even touch layer 3, everything is handled within layer 1 and layer 2. Isn't that crazy? I thought that for everything you actually sit down and use like network layer and IP, TCP, all that kind of nonsense. But guess what? If you're within the same network, it doesn't matter. You can literally just get the MAC address and have fun. It's that good, because of course, you use CAM addressing, or I think CAM components. Basically, they are extremely fast hardware memory sources where you can basically perform instant lookups. They're used in RAM. That's what I know. So I know that they're blazingly fast, and apparently that is what is used when you're within the same network. So when you want to converse with someone who's within the same network, right, router doesn't even do shit. It just sort of just stays back. It does absolutely nothing, because everything is handled within layer 2, right? So your data link, physical layer, those guys are the ones that are doing all the heavy lifting. Your network layer is sitting and enjoying. It's not even doing anything. The router is chilling. It's doing nothing, right? Because it's all within the same network. But let us go to scenario 2. What happens when, let's say, so let me look at this. Okay, so 192.168.1.100. Let's still assume that my machine is M1, 192.168.1.100. Let's say I'm still in this particular subnet, whatever it is. Let's say now I want to talk to server 2, which is in like some, let's say like 1.1. No, let's take some normal type address, I guess. 100.100.100. Let's say 99, something like, I don't know. I don't know what this address is, but assume that this is where I want to talk. This is the thing that I want. This is the particular IP address where I want to perform my communication, and we can perform, like, we can give it any subnet. It doesn't really matter. I'll just leave it be. I won't care. So what happens here is, so okay, again the machine goes, okay, this is my IP address, I want to talk to this particular guy. Now again you might wonder, okay, where does this IP come from? So I think oh yeah, I should also mention this. When this whole thing happens, this resolution of the MAC address, that is done through ARP, right, address resolution protocol, where you get the actual MAC address. The same thing essentially happens here as well, which is but here it is DNS, right, domain name system, where what happens is, let us say you're trying to, let's say a machine 1 is trying to access like a website called abcd.com or something, and it is hosted at 100. So a DNS thing is a DNS request is performed, then the IP address is fetched, and then the IP address finally gets to M1. M1 goes, okay, that's a very interesting looking IP address that we have, let's look at it. Then it performs the AND XOR test and basically figures out that, okay, oh my god, this guy is not within our network at all, this guy is like somewhere else, right, it's in some other universe, it's in some other network. What do we do? Well, guess what? This is where the router finally has to step up and it has to do its job, right? It actually has to sit up and sort of, actually perform a couple of stretches and, get ready to perform some action, some duties that it actually has to do. So what happens now is that, this guy, I mean, again, the machine does not give a damn. The machine goes, oh, so this guy's outside my network. Oh, well, I don't really care. It doesn't really care. It'll just go, okay, buddy, here you go. So to the router, what it'll do is, to the router, the information it will receive is, let's call it, so 192.168.1.10. I think that was the IP address we took, 1.100. It doesn't matter, right? And of course, you must remember, I think that is there are 4 key components whenever you're performing communication, right? I think 4 key components. So the source IP, which is this 192.168.1.100. You also have a destination IP, which we know is, I think, 100.100.100.99, right? That's what I wrote. And along with the source destination IP, you also have to, of course, provide the port in which you are going to perform a communication, right? Because that matters. Now let us assume that the source port right now is, we can take anything. Let's say 55661. This should be fine, doesn't matter. And then let us say that this guy, since it's a server, I don't know the actual HTTP codes or anything, so it's going to be like a very small port number. I think it's like we'll call it like 300 or something. I don't know what the actual port is, 300, but doesn't matter. Let's say we are doing a 300, it doesn't matter. Okay, so we tell to the router basically that within the IP, of course, we'll have the source and destination. In the TCP IP, we'll have the TCP part, will have the source and destination ports, right? So that will be present, of course. Now the router will look at this and it will go, oh my god, this guy is not in my network at all. Okay, so we actually have to perform some routing and we actually have to send this guy to the network. Okay, so now a couple of things will happen. The router will go, okay, so this guy, so it will try to make a note. So this guy 192.168.1.100, right, is trying to send a packet. So first of all, what it will do is it will change this source IP address, right? Remember, this IP address that you own is private. It is private to your own network. If you try to flash this IP address outside your own network, nobody will know who you are, because this IP address only belongs to you within your own network. Otherwise, it has no meaning. So now what's going to happen is this guy, the router, will look at this address and go, okay, so I have to send this packet outside, right? So technically, who is the sender here? It is I, right? I, the router, am the sender. Now let's say the router has some weird IP address like 200, 200, 200, 100. Assume it doesn't really matter what the IP is. Like, I'm just taking dummy numbers. I'm not sitting here to do actual calculation. It's all for demonstration, of course. So the IP address is changed, and of course, the guy, the router, kind of notes down that, okay, I'm doing this kind of a conversion, and also it notes down that the source IP was this, and the source port, that the port they were using to communicate, was 55661, and it will also note down that, okay, now the router might also have ports. Of course, it has a lot of ports. Now a couple of things can happen here. The router may have the same port available, and therefore it can just copy the same port and keep that same port open. Or if it does not have this port open and it has already given it to someone else, or it is communicating with this port with someone else, so it can just give you a new port. Not 321, let's not 3211, let's take this 32,111, right? But now, of course, the router will make an entry in its table and it will go, okay, any packet that comes to me with this IP 200, 200, 200, 100 with a port number of 32,111 actually belongs to 192.168.1.100 with a port number of 55661. It will keep a track of that. Okay, it will keep a track of that. Of course, it won't change the destination IP or the destination port. It will keep that as it is, and essentially your router, your router it looks like a TV but it'll send this port over to the nice little server. The server will then do whatever checks that it not checks. It'll basically reply. It'll reply again to whom? To the router itself, because router is the one that actually has any sort of public presence. And then the router is going to go, okay, oh my god, so we finally got a response at this port, which means that this response is actually meant for this guy, and then it'll basically send it to your device, right? So yeah, that's a laptop. That's what that's supposed to be. So yeah, that is basically how NAT works, and it's incredible actually how how kind of crazy all of this situation is. Honestly, it's so cool. Networking is slowly becoming one of my favorite subjects because of the craziness going on in it, and all of it makes sense. I find it quite nice as well. So yeah, that is about it. I'm thinking about going over DHCP once, and if I do, I'll make a video on that as well, because I'm finding these topics quite a lot of fun to cover. That's about it.